So in order to understand how we could even like multiply vectors or what it should mean to multiply vectors, we need to kind of have a different understanding of what it means to multiply normal numbers. So for example, if we look at a number line, 2 times 2, that means you add 2 to itself twice. So we start at 0, we go to 2, that's once, and we go to 4, that's twice. Or if we did 2 times 3, that means we want 3 2's, which means you go to 2 once, twice, and then 3 times over to 6. Or we could also think of that as 2 times 3, so 2 3's, we have once to 3, and then again over 3 over to 6. Then multiplication by a negative number is the same thing, just going in the other direction. So if we have 2 minus 2's, that means we start at the origin, and we go to minus 2, and we want another minus 2, so we go back another minus 2, and we end up at minus 4. Minus 2 times 3 would be 1, 2, 3, down to minus 6, and so on. So in order to understand how we can apply the same logic to vectors, let's kind of think about this as line or arrows. So if we write the 2 as a vector kind of like that, and let's say we do 2 times 2, we can kind of think about this thing that, I guess we might observe this thing, that if these two arrows are pointing in the same direction, it's going to be positive, because it means that they're kind of doing the same thing. So 2 times 2, for example, is 4. And if they are both pointing to the left, so if we had minus 2 times minus 2, well, they're still both going in the same direction. They're still both doing the same thing. It will still give you positive 4. And then if they're pointing in opposite directions, like 2 times minus 2, well then because they're kind of doing opposite things from each other, that's kind of like bad, then we go into negatives and we say it's minus 4. That might be a little bit confusing to understand, but let's think about it. We already know those rules of multiplication, and now we're kind of thinking about a different way of seeing those rules. So we already know those rules are true, and now we're kind of rewriting those rules in terms of directions and arrows. Now the only difference between what I'm doing here and vectors is that vectors aren't just going straight right or straight left. They could be going at an angle. So like this, for example. So what we're actually doing here is we're basically looking at an angle of 0 or 180 degrees. So basically what we're saying is we're taking the length of the two arrows, or how far away they are from the origin. So if we call this one V1 and call this one V2, we're taking the lengths of them, and these are vectors, sorry, I should be writing arrows above them. So if we have like a vector 2 and a vector 1, so we have the magnitude, the length of these vectors, we're multiplying those, and then we have something to do with the angle. We don't know what the angle is yet, and let's just call this the product of these two vectors equals this. Now we're not done yet, obviously. So obviously that'll give us the number, but then what determined if we had a positive or a negative? Well, if the angle was 0 degrees, then we had a positive, and if the angle was 180, we had the exact same number, except we just made it negative. So basically, we want to multiply this by something that, if the angle, which I'll call theta, is equal to 0 degrees, then it should be just V1 times V2, the magnitudes, and if theta is equal to 180 degrees, then we should have the minus version of that. Now, what is a function? So we're talking about angles, so obviously if we're using a function with angles, it's probably going to be sine, cos, or tan. Let's think about it. If we have sine of 0, that would give us 0, so then we multiply it by that. Doesn't really make sense. Okay, whatever. For that same reason, tan, since that's sine over cos, sine of 0 is 0, so multiplying by tan doesn't make sense. But if we look at cos, we notice something very interesting. If we plug in 0 into cos, we'll get positive 1. Obviously, that's something you should know. If not, it's kind of like expected that you know that. If you don't know that, that's like another video that I can make. But when you do cos of 0, so we can think about this as multiplying by cos of 0, and then down here, if you do cos of 180, that'll give you minus 1. So multiplying by cos, so instead of multiplying by a minus, you can kind of think about it as multiplying as cos 180. So what we notice is technically, if we're multiplying two numbers together, it's the same as multiplying by the cos of the angle between them. And this is true for the number line, okay? So basically, this is a new way of thinking about multiplication. So instead of thinking about is one positive, is one negative, we look at the angle in between them. So technically what that means is if we have one positive and one negative, the angle's going to be 180, that means it's negative. If the angle is 0, so even if they're both pointing off to the left, if the angle is 0, cos of 0 is 1, so it's going to be positive. So basically, we can just use this definition for any other vectors. So now we have a formula that works for any two lengths and an angle. So now we're not limited to the number line, now we can extend this to the Cartesian plane. And for example, we could take this And we could do like that, and then we could take this, and now look, we still have two different lengths, and we have an angle between them. So instead of thinking, oh, how could we like define this? Well, we don't need to worry about it, because we have this definition, which came from the number line.